Good morning, students. Now we are going to discuss the definition of sequence and some theorems on sequence, right? Now, what is the definition of a sequence? Let please go through the definitions. Let A be a non-empty set. A function from n to a can be defined as a sequence where n stands for set of natural numbers, right? Now, definition of a sequence, another definition: a function s from z plus stands for set of positive integers to real numbers is called a sequence of real numbers or simply a sequence. Now, we denote a sequence by these are the notations of a sequence. Now, let us discuss about the definition. Now, here suppose A is a set, B is a set, right? F is a mapping. F is a mapping from A to B. Then how will write? F from A to B, right? Is a mapping. Now here function means function here. Now here I want first set codomain must be a natural numbers, domain must be a natural number, and codomain must be any set, right? Now a function f is a function from n to a where this is called domain, right? Domain, and this is called codomain, right? A function from set of natural number to a set. A may be any set, any subset of real numbers, right? Now this function is called a sequence, right? Suppose if S is a mapping, here I'm changing the notation, right? Now F you can use, or S you can use, or G also you can use. S is a notation, it is a symbol. S is a mapping from N to R, right? N to R. Here domain is set of natural numbers, codomain is set of real numbers. Then this function is called a real valued sequence or sequence of real numbers or simply a sequence, right? N stands for set of natural numbers. Another definition is S from Z plus 2R. A function s from z plus 2r. Here what is z plus? Set of positive integers. This is nothing but set of natural numbers. No, set of positive integers is nothing but set of natural numbers. 2r is called a sequence of real numbers or simply a sequence. Sequence is generally denoted by this notation Sn or R within braces Sn or R within parenthesis Sn or R within braces n running from 0 to infinity. These are the standard notations, or they can write Sn from n tends to 0 to infinity. These are the standard definitions. Sometimes they will give Sn from n running from 1 to infinity or Sn from n running from 1 to infinity, right? So n running from 0 to infinity, sometimes n from 1 to infinity. Now the standard definitions is Sn, n running from 1 to infinity is the standard definition of a sequence. It is notation. What is the notation of a sequence? Sn is Sn, n running from 1 to infinity is the standard notation or standard definition of a sequence, right? Now, here, what are the examples of a sequence? Sn is equal to n square. That means here the nth term of a sequence is given to you, right? Not the entire sequence, only the nth term of a sequence is given to you. Now, n is equal to, if you put n is equal to 1, what you will get? S1, right? S1 is equal to, in the place of n, I am substituting 1 whole square is equal to 1. Right? N is equal to 2. What you will get? S2 is equal to 2 square, that is 4. N is equal to 3 if you substitute. S3 is equal to 3 whole cube 9. Now what are the terms of the sequence? S1 is the first term of the sequence, S2 is the second term of the sequence, S3 is the third term of the sequence, and so on. Sn is the nth term of the sequence, and so on. What is the S1 value? Here 1. S2 value is 4, S3 value is 9, so on. Sn value is n square, the nth term is n square, and so on. This is the sequence, right? Whose first term is 1, second term is 4, third term is 9, and so on. Nth term is n square, n plus 1th term is n plus 1 whole square. These are the notations, and where S1 is the first term of the sequence, S2 is the second term of the sequence, S3 is the third term of the sequence. Similarly, Sn is equal to nth term of the sequence. Now second example, another example, Sn is equal to minus 1 power n. Right? Here clearly the nth term is given. The nth term of a sequence is given to you. Now how to get the first term? Put n is equal to 1 in the nth term. S1 is equal to minus 1 whole power 1. Right? That is minus 1. Now put n is equal to 2. S2 is equal to minus 1 power 2, that is 1. Put n is equal to 3. S3 is equal to minus 1 whole power 3, that is minus 1. Therefore, what are the terms of the sequence? S1, S2, S3, S4, and so on, right? Now to the what is the first term value? Minus 1. Second one value is 1. Third one value is minus 1. Fourth one will be 1. Fifth one will be minus 1, and so on. These are the terms of a sequence. Right? Another example is there. Some an is equal to minus 1 whole power n greater than or equal to 0. క్లియర్గా ఇలా మెన్షన్ చేస్తాడు వేర్ n గ్రేటర్ దాన్ ఈక్వల్ టు 0 అని. అక్కడ డిఫైన్ కూడా చేశాడు. a0 ఈజ్ ఈక్వల్ టు సమ్ 1 అని ఇస్తే నా ద ఫస్ట్ టర్మ్ ఇక్కడ ఏమవుతుంది? a0. క్లియర్గా మెన్షన్ చేస్తే దిస్ a0 విల్ బి ద ఫస్ట్ టర్మ్ ఆఫ్ ద సీక్వెన్స్. Right? How to get the next term of the sequence? And n is equal to greater than or equal to 0 అని ఇచ్చాడు కదా. నెక్స్ట్ టర్మ్ ఏమవుతుంది? 0 తర్వాత 1. పుట్ n is equal to 1 అంటే ఏమొస్తుంది మనకి? a1 is equal to minus 1 whole power 1, that is minus 1. Similarly, n is equal to 2. If you substitute, what you will get? a2 is equal to minus 1 whole power 2, that is 1. Right? Now what about the terms of a sequence there? Now we can write 1 minus 1, 1 minus 1, and so on. These are the terms of this sequence clearly. Now please go through the examples carefully.